Trigonometry can be used to find the sides as well as the angles of a right triangle. In order to find the missing sides of a right triangle, we used our trig functions and the trig ratios. One of those values within the trig ratio was usually an unknown for our unknown side, and our angle was always given. When you're given at least two sides and an angle is unknown, you need to use inverse trigonometry. In order to find angles using trigonometry, we need to first review our trigonometric functions. Sine is the ratio of the opposite side over the hypotenuse. In this case, the opposite side is the side that is not touching the angle that you're solving for. The hypotenuse is always the side that's directly across from the 90-degree angle. So if I have sine of B, it's side B divided by side C. Whereas the sine of angle A, if I was trying to find angle A, would be A over C. Side A is opposite from angle A. Cosine is another trigonometric function. It's the ratio of the adjacent side over the hypotenuse. The adjacent side is always the side that the angle is touching. Now in this case, angle B, so if I was solving for angle B, for example, side A and side C are touching. Side C is a very specific side. That's the hypotenuse. It's the longest side and it's always directly across from the 90-degree angle. So in this case, the adjacent side is A. The hypotenuse is C. So the cosine of B is equal to side A divided by side C. Cosine of angle A would be B divided by C. B, side B, is adjacent to angle A, and C is still the hypotenuse. Our last trigonometric function or trig function is tangent. The tangent is the ratio of the opposite side over the adjacent side. So I'm going to take the opposite divided by the adjacent. If I'm looking at angle B, to find the tangent of it, I would take side B, which is opposite, it's not touching the angle, and adjacent, which is side A. That's how I get tangent of B equals B divided by A. For tangent A, or tangent of angle A, the opposite side from angle A is side A. It's the side that the angle is not touching. The adjacent side to angle A is side B. It is the side that angle A is touching that's not the hypotenuse. We remember our trig functions and the ratios that go with these functions using the saying SOHCAHTOA. SOHCAHTOA stands for each of our three trig functions: sine, cosine, and tangent. The first one, SO, is sine, which represents the ratio of the opposite side divided by the hypotenuse. Cosine represents the ratio of the adjacent side divided by the hypotenuse. And tangent represents the ratio of the opposite side divided by the adjacent side. Remember, opposite sides are the side that the angle is not touching at all. The adjacent side is the side that the angle is touching that's not the hypotenuse. And the hypotenuse is always the longest side, the side that is directly across from the 90-degree angle in our right triangle. Some people benefit from writing SOHCAHTOA in a different way. Here we have big S, that represents sine. Here we see the ratio of opposite divided by hypotenuse. Cosine, big C, which is the ratio of adjacent divided by hypotenuse. And then TOA, which is the tangent, which represents opposite divided by adjacent. These ratios become very important. This time around, both the top and bottom, the numerator and denominator, what have you, of the ratio is going to have an actual value. We no longer will have a variable here. We're not looking for a side. We're using this ratio to look for an angle. To do that, we need to use a special trig function. Sine, cosine, and tangent all have inverse functions. For calculation purposes, these functions are usually the secondary functions on your calculator. So to access the inverse of sine, you would hit second and then the sine button. Cosine, you would hit second, cosine. To hit inverse tangent, you would hit second, tangent. But long before we can actually calculate these angles, we need to set up some information using our previous trigonometry knowledge. We start by determining which trigonometric function the problem represents. In this case, we're given one angle, two sides. The angle is the angle that we're focusing on. This is the angle that helps us determine what is opposite, what is adjacent. Once we know what's opposite, what's adjacent, what's hypotenuse, we can determine which trig function we're going to use. To determine which trig function we're going to be using, we need to look at the two sides. The two sides are always the ones that are given to us. In this case, 5.4 and 9.886. We're going to use the angle that's marked with that theta symbol. The theta symbol is a variable. It usually represents angles. Just like x usually will represent an unknown value in an equation, theta represents an unknown angle in a triangle or in any angle measure. This is the angle that helps us determine what's opposite, what's adjacent. It helps if you put yourself in the perspective of that angle. Imagine you're standing on that triangle. To your left-hand side, you see line segment CN. That's not labeled, so it's not important. Across the triangle, far out of your reach, is line segment CY. That side is 5.4. It's opposite. I cannot touch it. It's beyond what I can reach from that angle. Then I also have 9.886 off to my right. That is my hypotenuse. It's directly across from the 90-degree angle. So my adjacent side is not represented. My opposite side is 5.4, and my hypotenuse is 9.886. I'm dealing with an opposite and hypotenuse, so I think SOHCAHTOA. Which ratio involves opposite and hypotenuse? Sine, so. When we were solving for unknown sides in a right triangle, we would put the given angle next to sine. We'd be finding the sine of a known angle. Here we're finding the sine of an unknown angle, but we do know the two sides. Sine is opposite over hypotenuse, hence so in SOHCAHTOA. So my opposite side, the one I cannot touch if I'm standing on that angle, that's 5.4. So that's going to go up top. I'm going to use these given sides to represent the trigonometric ratio. So opposite is 5.4 divided by the hypotenuse, which is 9.886. So sine of theta equals 5.4 divided by 9.886. At this point, you might want to try to solve this. You might divide by sine or multiply by 9.886, just trying to use those inverse operations. There is no operation that we've discussed previously that'll help us. In turn, we need to use an inverse function. So what happens when I use the inverse of sine? I switch out the ratio on the right side of my equation and the theta on my left side. So if I need to find what the theta or the angle measure is, I'm going to plug in inverse sine 5.4 divided by 9.886. This equals theta. I'm going to substitute the trigonometric ratio into the inverse trigonometric function using a calculator. So in this case, I would hit second sine. That'll give me my inverse sine function. And it's going to open a parentheses for me. I'll type in 5.4 divided by 9.886, close parentheses. When I plug that into my calculator, I end up with an angle of 33.11 or 33.11 degrees. That represents the angle measure of the unknown angle. From here, if this problem extended into a further problem or a larger diagram, we could find angle CYN, or angle Y if you want to simplify it, by simply adding up 90 and 33.11 and subtracting that sum from 180. Or because we know it's a right triangle, we can assume 90 minus 33.11 would equal angle y. Let's try another problem together. So we have an unknown angle marked by theta. We have two given sides. We need to understand the ratio or the relationship between those sides. It helps if you put yourself in the position of theta, of that unknown angle. I can touch 5.8. I can touch that side. It's adjacent. It's not the hypotenuse because it's not straight across, so I know it's my adjacent side. The side that I can't touch is 8.298. That's my opposite side. I can't touch it. I have opposite, which I can't touch, the adjacent side that I can touch, so I have opposite and adjacent. What trig ratio is opposite and adjacent? So, ka, toa, oa, opposite, adjacent. So I'm going to take tangent of theta, so tangent of the unknown angle, equals the trig ratio. Opposite over adjacent, toa. Opposite is 8.298 divided by the adjacent 5.8. I'm going to use my inverse trig function. So take the time to write this out. The inverse trig, tangent function, when I do that, I switch out my ratio on the right side and my theta on the left side. The inverse tangent is what does this. So inverse tangent of 8.298 divided by 5.8 equals theta. The theta and the ratio switched places when I took the inverse tangent. In my calculator, if I hit second tangent and then type in the ratio 8.297 divided by 5.8 and hit enter or equals, I'm going to end up getting an angle of 55.04 degrees. If you find that you're not getting these same answers, make sure that you're doing this on a legitimate calculator, no cell phone calculators, and also double check that that calculator is in degree mode. Some calculators can be in radian mode, which will not give the same degree measures that we're looking at here. When you're using the inverse trig functions, you're solving for angles. So in this case, my answer of 55.04 degrees is equal to my theta, my unknown measure. I can now use this angle in order to find my unknown angle JLV, or angle L. On your own, try these two problems. Take time to figure out which trig function is represented by the two sides that are given. Write out the trig function with an unknown angle. Set up the trig ratio using SO, CA, TOA, which explains those trig ratios for you. Use your inverse trig functions on your calculator in order to evaluate the missing angle measure.